This is a short presentation on the use of variables in C++. We use variables to store information that we can retrieve and use later in our program. Variables in C++ have a type, a name, and a value. And in our programs, we will want to store information for whole numbers, decimal numbers, and single ASCII characters. We'll start with whole numbers. The type is int, which is short for integer, which means whole number in math. A typical variable we might want to store information for might be the number of students in our classroom. Therefore, we would have a variable name that says number of students. Since we have 24 students in our class, the value would be 24. And we could declare our variable as follows: int number of students equals 24. So now we have a place in memory called number of students to store a whole number, and we've placed a value of 24 at that storage location in memory. Note we end the line with a semicolon. We might also want to store decimal numbers with up to 6 decimal places. We call those float variables, and a typical value we might want to store could be the average grade for a student in a class. And a typical value for that grade could be 87.4%. So our line of code to declare this variable would look like this: float, the type, average grade, the name, equals 87.4, and we follow it with a semicolon. Sometimes we want decimal numbers with more decimal places. We can store up to 14 in a variable called double. Double has twice the allocation of memory as float, hence it's called double. A typical variable we might want to use more decimals for could be pi. And this is the value of pi, up to 14 decimal places. So our line of code would be double the type, pi the name, equals this value for pi, and remember it's followed by a semicolon. Finally, we might want to store single ASCII characters, i.e. a single letter, a single number, or punctuation mark in memory. To do this, the type is char, where char is an abbreviation of character. An example might be letter grade. And if we remember that we used 87.4 for the value of average of, the letter grade corresponding to that particular average of would have a value of B. This is our line of code then for declaring a letter grade variable of type char. Char letter grade equals B. Note that when we assign a value to a char variable, we place the value inside single quotes. You must do this, otherwise the program would be confused and think that letter grade was supposed to be equal to a different variable that had a name B. So, always remember, when we assign a value to a char variable, we place it inside single quotes. Good variable names are important in any program. First of all, they must be intuitive. The name must match the idea. So for our char variable that we wanted to store whatever our letter grade was, why not use the word letter grade? Because it means exactly what we were thinking in the first place. We also must remember that all variable names may have no spaces. That's 0 spaces. So, letter grade was okay because the word letter and grade had no space between them. It was all one word for our variable name. Average grade, as we used it, or number of students in that case, also were okay because average underbar grade has no space in it. We use the underbar instead of a space. Now, the 8 lines shown in yellow are the next program that we'll complete. So stop for a moment and place these 8 lines into your notes. We have 4 variables declared. Int, number of students equals 24. Float, average grade equals 87.4. Double, pi equals 3.14. 159265358979. And char letter grade equals B, where B was assigned inside single quotes. Then we have 4 cout statements that allow us to recall in the program whatever value was stored in our variable and place it on the screen. So cout, number of students inside quotes, would give us that as a label, which is exactly like our cout statements prior to this point. Then we see inside new alligators the variable name number of students with an inline. When we do this, number of students, since it's a variable name, will then allow us to place whatever value number of students contained in memory and place it here on the screen. When you type this program here in a few minutes, you'll type it exactly like this, where you place number of students as a variable name in the cout statement, not the number 24. So, once this is in your notes, you'll create a new program called var.cpp. You'll place these 8 lines of code in the program and get it to run. Remember, you must add the 5 lines of code that we use in every program. You know what those 5 lines are. If not, go back to look at Hello World and use your notes as needed. When you're done, take a look at what happens when we cout the value for pi. You'll only see 5 decimal places because that's the default number of decimal places that a cout statement will place on the screen. And we know we gave it up to 14. When that happens, make a copy of the program called var2.cpp. Then we're going to add 2 lines of code in front of the cout statements. We will be setting precision. Precision in this case simply means the number of decimal places we want to see on the screen for our decimal numbers, whether they're float or double. Obviously, this won't work for ints and it won't work for char variables. The 2 lines are as shown. What we're doing is we're setting a fixed precision of 15. You can place these immediately in front of the cout statements where you want the exact precision shown. If you want all of your decimal numbers to have this many decimal places, then in fact you could place this once in front of all those cout statements. You wouldn't need to do it each time. On the other hand, if you wanted a different number of decimal places for different variables, you could place this code as many times as needed, setting the precision you want each time in your program. Once you've gotten this done, you'll see that when you look at average of, it'll give you 15 decimal places, even though you only had valid information for 1. And when you look at pi, you'll see you got your first 14, and on the 15th it's simply added 1 that really had no value because that information wasn't stored. Once you're comfortable with this, play around a little bit by taking the 15 and putting in the number 250 and then watch what happens. Okay, now you're ready to use variables in C++ programs. Let's get our program completed.